So let me just explain the energy quantization for you. So we'll now move to the new Google energy quantization. So you should know this energy quantization. It is with emission of radiation. You understand? So electromagnetic they when it deals with what emission of what electromagnetic spectrum, you understand, or radiation. So radiations like photons or quantum, you understand me. So let me take for example instance now. So when light is emitted, they are emitted in discrete amounts, or you can say fixed or separate amounts, you understand. But so when lights are emitted, or when um, electromagnetic radiations are emitted in separate, fixed, or discrete amounts, you understand. So that's it. So under this now, there is one concept we know as energy level. You understand? That means the energy state in which the radiation was before, compared to the energy state it is now. You understand me? So let's take for example, let's say an energy level, radiation can jump from lower energy state to to an higher energy state. So when it does that, you should know that it has absorbed energy. Energy is absorbed. You understand? Energy is absorbed. You understand? So jumps from when it jumps from higher energy state to lower energy state, you should know that it has emitted energy. You understand me? So let me drop some useful formulas for you so you can know. So you should know that under this topic, um under energy conservation, we have these formulas. We have E is equals to HF. We have E is equals to AC over lambda. We have E is equals to what? Initial energy E naught minus final energy. You understand? So let's say the the initial energy was the higher energy level. You should know that the our initial energy will be our energy higher energy level will be E naught. But when the lower energy level is our final energy level, it will be E1. But if the reverse is the case, you should know what to do. You understand me? Let's say the reverse is the case now. Let's say if the lower energy level is the initial energy level, you should know that it is the lower energy level we put here. But if the higher energy level is the final energy level, you should know it is what we put here. You understand me? So that's just it. So that's just it. I will still post questions so we can solve on this topic. So I want you to take note of these formulas. You understand me? So now that we have known the basic of this topic, so let's talk about we have known the formulas. E is equals to Planck constant, energy state of the radiation, be it photon um or any other radiation. E will be equals to HF. E is equals to HC over lambda. E is equals to E naught minus E1. So you should know that this is Planck constant frequency, Planck constant speed of electromagnetic radiation. This one is lambda. So let's look at some questions we can apply these formulas to. So let's look at number first question. They said an electron makes a transition from a certain from an electron makes a transition from a certain energy level to the ground state E naught. You understand? If the frequency of emission is 8.04 0 times 10 raised to power 14, the energy emitted is, so you should know in this number one question which formula we to use when we state the parameters. We have f, parameters are f is equals to what, 8.0 times 10 raised to power 14 hours abi. So there is one constant. You should know the constant. We have to use A is equals to HF. You understand? Because H is a constant. So in the second question, we are given the value of H, which is H is equals to 6.6 times 10 raised to power minus 34 joule seconds. You understand? So let's apply it. Let's solve the question at the back of our book. So solution. Don't mind my writing. I'm very sorry for the unclear handwriting. So we have E. So when you look at it, you see they said it jumped from. You should know that this E is equals to E, abi, the initial energy level minus what, the final energy level is equals to HF, abi. So that is it. It said an electron makes a transition from a what, certain energy level. This is the energy level it was before it jumps to the ground state, which is this one, this final state. You understand me? So let's solve my guys. Let's solve. So we have E K is equals to what, E O minus E1 is equals to what, HF. So we are being given our H to be what? Our H is 6.6 times 10 raised to power minus 34, abi. 6.6 times 10 raised to power minus 34. What's our frequency? Which is what? 3 times 10, which what? 3 times 10 raised to power what? Minus 3 times, sorry, which our frequency is 8 times 10 raised to power 14 rather. 8 times 10 raised to power 14. So let's use the power of indices here. So we have 8 times 6.6 is what? 52.8 times 10. You should know what I did there from our mathematics indices. So minus 34 times minus 34 plus 14 is what? Is minus 20. You understand me? So let's keep on finding. So we have 50. Our answer to be what? 52.8 times 10 raised to power what? Minus 20. She understand that joules. She understand me? So that's our what? That's our answer. She understand me? So that's our answer. So let's solve the next question. It said calculate the energy carried by an X-ray of wavelength 6.0 times 10 raised to power minus 10. Which plus constant? Okay, good. So from the formula you can see H is equals to HF, E is equals to H is lambda, E is equals to E naught minus E1. So which one are we to use? Since we have seen wavelength here, you should know that this is the formula we have to use. So we have E is equals to HC over lambda. Do you understand me? So calculate the energy carried by an X-ray of wavelength. So plus constant velocity of light. So our velocity of light is, which is electromagnetic wave, is a light. So 3 times 10 is power 8. So let's plug in our values. We have E is equals to 6.6 times 10 raised to power minus 34, abi, times 3 times 10 raised to power 8. What's our wavelength? Our wavelength is 6.0 times 10 raised to power minus 10, abi. 6.0 times 10 raised to power, let me, 6.0 times 10 raised to power minus 10. 6.0 times 10 raised to power minus 10. So we should be able to do this one with our head. So we have 6 here, 1.1, abi. 6 here, 6.0. So 6 here, we have 1.1 times 6 here, 1, abi. 1.1 times 10 raised to power minus 34 times 3 times 10 raised to power 8. Just be looking at the way I'm solving it though. Because UI post TM does not require to use calculator. So please and please, 10 raised to power minus 10. She understand me? So we have This one we let's plug in this one to this one. So we have 1.1, um we have 1.1, so we have times 10 raised to power minus 24, abi, so times 3 times 10 raised to power 8. So we have what? We have 3.3 times 10 raised to power minus 16 as our answer. She understand my point. So let's do number 3. Let's do number 3.